Today we will begin talking about various properties of motion. First, we're going to define and give some characteristics of each property. Then we'll look at how these properties appear on a graph. And next, we'll learn how to calculate the properties. Today's notes focus specifically on the definitions and characteristics of properties of motion. Kinematics is the study of how things move. And all properties of motion fit into two general categories, either scalars or vectors. Scalars are properties that only have a magnitude, or just a size. So, a dozen eggs, there's only the size. There's 12. Okay. Temperature is another physical quantity that's represented by a scalar. It's just the amount. So, negative 20 degrees is negative 20 degrees. It's not 20 degrees up, 20 degrees down, or 20 degrees south. It's just negative 20 degrees. Vector properties, on the other hand, have both a magnitude and a direction. If you're a fan of the movie Despicable Me, think about when Vector's at the bank and he says, I'm no longer going to be Vector, I'm going to be Victor, because it has a size and a direction. That is the correct definition of a vector. So anything that is a vector, we're going to represent with an arrow. Okay, the direction the arrow points is the direction of the vector. And the length of the arrow is proportional to the magnitude of the vector. So a small arrow would represent something that's small in size. Okay. And the term magnitude just means how much of it. Okay. Or how fast is it going, or how far. So that's the number value. That part will be the same for scalars and vectors, but the difference is our vectors have a direction. So maybe instead of saying we're going to drive 10 miles, we would say we're going to drive 10 miles north. Now we're going to discuss different properties of motion that fit into each category. First, we're going to focus on our properties of motion that are scalar properties. All of these properties will always be positive because it's just the size. So, time, distance, speed, and position are the four main scalar properties that we're going to focus on in this class. The first scalar quantity we're going to talk about is distance. Distance is simply how far the object traveled, and it's going to be measured in meters. Okay, so if we want to drive to Midland, our distance would be approximately 20 miles, depending on what part of Midland we're going to. If we want to go to Midland and come back, our distance would be somewhere around 50 miles, depending on what we did in Midland. Our next property of motion is speed. This is the distance traveled per unit of time. This is basically how fast something's moving. And speed is a rate, in this case, distance per unit time. And so our units are going to be the unit for distance divided by the unit for time, which is meters per second. Alright, next we're going to cover vector properties. Vector properties are can be both positive and negative. And examples include displacement, velocity, and acceleration. The first vector quantity we're going to cover is position. The position is where the object is located. It's measured relative to a zero position or the origin. Okay. Positions to the right or also above the origin are positive. So if we're driving a car, if the car is to the left of the origin, it is going to be negative. We're also going to consider south and west as negative directions as well. The farther we get to the left of the origin, the larger the value will be, but it will still be negative. And position is a length, so just like any other length, like height or width, we're going to measure it in meters. As we begin working with equations, position is going to be represented with the variable x, or sometimes y if we're talking about a vertical position. The initial position, or the starting position, is going to be x sub I. The I is a subscripted letter, which means it needs to be positioned to the right and lower than the x. We will also have an x sub f, which stands for the final position, or the ending position. Our next vector quantity is going to be the displacement, which is how far an object is from where it started. Okay. This is the length of the shortest path between the initial and final points. So basically, it's our distance, but in a certain direction. So when we spoke about distance, we talked about going to Midland, and we said we would have traveled about 20 miles. Well, in order to turn that into a displacement, we would say we are 20 miles east of Odessa. Okay. Now, displacement can be positive and negative. And that's how we indicate the direction. Just like with position, up and to the right, or north and east, are positive, while down and left, or west and south, are negative. Our displacement can also be zero if we get back to where we started. So let's go back to our analogy of going to Midland. If we go to Midland and we stay in Midland, our displacement will be approximately 20 or 25 miles, depending on what part of Midland we're in. But if we go to Midland, go shopping, and come home, our displacement will be 0 because we're back where we started. Football players, you can think of it as the distance is the length of the route that you ran, but the displacement is the number of yards you gained or lost on the play. Now let's move on to velocity. Velocity is just basically the speed with a direction. Okay? A ball being tossed up in the air has a different velocity than one falling down at the same speed, simply because one being tossed is going up while the other one's going down. So one would be positive and the other one would be negative. Okay, we're going to use an arrow to represent this vector again and indicate the direction. Okay, we also use the mathematical sign to indicate the direction. Once again, positive is anything that goes up or to the right, which is north or east, and negative is anything that goes down or to the left, which are west and south. We can have two types of velocity. The first is the average velocity, and that's velocity over a long period of time. So let's go back to our analogy of going to Midland again. Say we're going to go to Midland, and we know it's about 20 miles, but it takes us 30 minutes to get there. Okay. Over the course of the whole trip, we would be doing approximately 50 miles an hour. Okay. But along the way, there's stop signs or stoplights or other traffic, and we have to speed up and slow down. So we're not traveling at 50 miles an hour the entire trip to Midland. What the speed that we are traveling at that very instant is what we call our instantaneous velocity. That's the reading that we get from our speedometer, and that's what the cost-based speeding ticket's off of. Our last property of motion for today, and for this first unit, is acceleration. Acceleration is the rate of change of velocity. So basically, how fast can your car speed up? Those of you that are into muscle cars and racing, this is where we look at how fast can the car go from 0 to 60. Okay. We want, if you want to race, you want that to be the longest or the shortest time possible. You want to have the greatest acceleration possible to get your car moving quickly so that you can win the race. Okay. So if we increase the acceleration, the velocity changes more quickly. If the acceleration is negative, and the opposite direction of the initial positive velocity, then that means our car is going to slow down, change directions, and speed up again, going in a negative direction. So with acceleration, just because it's negative doesn't necessarily mean we're going to the left or down like it did when we were looking at displacement and velocity. Okay. We will go through more and more details of each of these properties of motion over the next few weeks. Starting tomorrow, we'll look at what graphs of these properties of motion look like and how different graphs represent different scenarios of what's happening when an object is moving. I will do my best to incorporate examples from all kinds of things that students are interested in, but if there's something specific, just let me know and I'll make sure I try and include those examples in the next video.